So in this video, we are going to talk about another method for solving quadratic equations, and that's by completing the square. Let me just preface this by saying that completing the square is by far the least favorite method of solving quadratics that students encounter. And that's because it's really cumbersome, there's a lot of steps in it, but completing the square actually has a lot of uses. It will always work when we are trying to solve quadratics. More importantly, we end up using completing the square in other areas of math as you move along, and so that's why it's really important. So, having said that, keep it in mind that you may not like it, but we got to do it. So, before we get into completing the square, though, we need to remember what a perfect square trinomial is. Perfect square trinomials are trinomials, or three terms, where the first and the last terms are perfect squares, and this middle term is twice the product of these two roots. Now, having said that, the trinomial, perfect square trinomial, will factor into x plus 3 times x plus 3. Well, we know we can rewrite that as x plus 3 quantity squared. Here's another example of a perfect square trinomial where I have x squared plus 4x plus 4, which would factor into this. And here's another one which would factor into this binomial right here. Now what that gets for me is, if I have on one side of the equation something that I can factor into a perfect square and rewrite it like this, and that is equal to, I don't know, some other number, then we can, if we have this set up, then we can go back and we can apply what we learned about the square root property, take the square root of both sides, and then we can solve. So that's kind of the reason why we're looking at this. Now, these perfect square trinomials are special cases of trinomials, and they don't always exist. So how can I force a quadratic into this form right here so that I can then apply my square root property? And that's really what this is about. These are the steps. There's 6 steps that we're going to use to be able to complete the square and then solve the equation. And you can read over these steps after the video because it's a lot easier if I just jump in and show you how it's done. So those are the steps up there. Now, we're going to start with this first example here, x squared minus 2x minus 5. What we want to begin looking at is my leading coefficient, my a, which is the coefficient next to my squared term, is a equal to 1? In this case, a is equal to 1, and so that's great. We can move on to the next step. And we'll work an example when a isn't 1, but this is, so yay, let's move on. If a is equal to 1, the next thing we want to talk about is my c term, which is this negative 5. I want to get him over on, I want to move him over to the right-hand side, leaving me with just these two terms on the left. So we're going to rewrite this as x squared minus 2x, and I'm going to leave a big blank spot there, is equal to 5, because I took 5 and added it to the right-hand side. Now we are going to go and we're going to talk about my b term. The negative 2 is my b term, and this is where we are kind of manipulating or applying the completing the square part too. So what we do is we take half of my b term. When I take half of b, that is really multiplying my b term times 1/2. So 1/2 times negative 2 is a negative 1, which we are going to square, and negative 1 squared becomes 1. Now if I were to add 1 here to the left-hand side, I am creating a perfect square trinomials. First term is a square, last term is a perfect square, and the middle term would work out. If I add 1 to make my perfect square trinomial here, then I also have to add 1 to the right-hand side to keep my equation balanced. And now I can simplify. So the goal was to get a perfect square trinomial that I could factor into something squared. And it is no secret, or I guess it is no coincidence, that this negative 1 term here is going to show up here in my factored binomial because that is x minus 1. And that's how come I keep a running total of these things over on the left, because I don't have to do any fancy factoring. I go back to this guy right here, I stick it in my parentheses, I'm done. That's going to be equal to the 6 on the right hand side. And look what we have. We have a perfect square equal to a constant where we can come in, apply the square root property, and say x minus 1 is equal to plus or minus the square root of 6. Okay, because I can't take the square root of 6 and get a number, a simplified number. I can take the square root and get a decimal value, but there's no perfect square factors of 6 to make this number any smaller, so this is what we leave it as. And now when I solve for x, or I get x by itself by adding 1 to both sides, we can write this as 1 plus or minus the square root of 6. Again, I can get a decimal answer if I take 1, add it to the decimal value of the square root of 6, or 1 minus the square root of 6. This is the exact answer, and a decimal answer would simply be an approximate answer. So there's my two solutions for my quadratic. Now let's look at another example that we have right here where I want to solve by completing the square, this quadratic right here. We said in the previous example that we want to make sure that my a term, or my leading term, is a 1, and that's not what I have here. So I need it to be a 1, and I get that by dividing all terms in the equation by the number 2. And that's going to give me x squared here plus, and I am going to leave my fractions as improper fractions and just as they are. I'm not going to change them to a decimal. So right here, this is when we're going to embrace our love for our fractions, okay? And we're going to be okay with it because we have a cool calculator that handles fractions for us. So I have the left-hand side, which is just 2 terms, and I have something over on the right. This is what I want. Now we're going to take my b term. That's the 5 halves right here. And remember, we take half of b. When I take half of b, that's like multiplying b by 5 halves. When I multiply two fractions, I multiply numerator to numerator and denominator to denominator. So I get 5/4. Now 5/4 is what I'm going to square. When I square a fraction, I square the numerator, which is 25, and I square the denominator, which is 16. Okay, so 25/16 is what I have to add to both sides of my equation to keep it balanced. Now let's go and and remember that created our perfect square trinomial, which doesn't look like it to me. I know it is, but it's not very obvious because of all these fractions, but it is. So we want to factor this guy into its square. Now remember my trick. I told you that this number right here is what shows up right here. And we have a positive 5/4, which I should have put that in there. But this is going to be a positive 5/4 here. So see, I don't have to do a whole lot with that. And then equals, now I'm going to go pull out my calculator if I don't want to add these two fractions together. And let me show you how we would do that on our graphing calculator. So let me make this smaller just a second. Okay, so I want to add 3 halves with 25/16. So on my calculator, and here's the screen over here on the right, I'm going to put, anytime you add fractions, you have to surround them with parentheses. So I put parentheses 3 divided by 2 plus, open parentheses, 25/16. My calculator takes a little while to respond. 25 divided by 16. Close my parentheses. Now, I want the result of this in a fraction form, so I hit Math, and fraction is the default, so I hit Enter, and I hit Enter one more time, and it gives me that those two fractions added together is 49/16. So see, I don't have to, I can embrace my love for fractions. 49/16 over here is what happens when I simplify these two. Now, Now that we have it in this form, we're going to come back in. We're going to take the square root of both sides.